Hey, can you hear me?
Yeah. Okay.
Hey, sorry, it took me a bit to understand what you're doing with the lock. I think I understand what's going on now. I totally forgot that gates aren't locks.
Yeah, and I and like I wrote now, I'm not sure that I couldn't that it's worth the effort. I could have just used one big read-write lock.
I think that's actually the play, to be honest. The reason I say that is straightforward. Mutations to listeners never happen, like to a first approximation. It's only during setup and shutdown.
Yes.
So that table sort of never mutated.
Yeah, I think. Yeah, and I cling to the design just because it's the way I started it, but I thought
Yeah, no
about it
worries.
this morning.
If it were more dynamic, this would make sense. It's just that right now we don't have anything that registers and unregisters itself a lot. Probably because that operation is very expensive in classic OSD because of all the global locks you have to take.
Mm-hmm. Okay, I think you're right. I should have. I can just kill this whole mechanism and use just the one main lock. The code will be much simpler.
And I wouldn't worry too much about the efficiency of the lookup table because it's never very big. The only entity that shows up in there a lot are the PGs themselves, and there just are never that many of them on a particular shard. Like order of tens to hundreds, never of thousands.
Okay. Okay, so I do that, and there will be another version of the code. And by the way, not just to you, thanks for going over the code.
Hello guys.
Hello?
So let's
Everybody.
start. Hello. Hi. Last week I was working on I was reviewing SeaStor to add the object context registry to Crimson, and was also struggling with the B+3 implementation. The goal is to try to figure out the interface interacting with the allocator and the journaling, and also trying to shape the B+3 as simple as possible, and try to avoid premature optimistic. And it's me. Treme.
Hey, 1 second. Kifu?
Yes.
Can you send some or the chat some pointers to what you are doing so I can learn what is the code that you are trying to do? And
Okay, I'll send a branch offline, but it's a very preliminary here change.
I understand, but thanks. Just for my education.
Okay, cool. Will do.
Thanks.
And Treme.
I sent out the FL test, and it seems for the right and only I do 2 cases for the number jobs. If it is equal to 1, and premise OSD seems better than the self OSD in most cases. If the block size is bigger than 4K, is bigger and equal 4 megabytes, and it seems better. But if the number of jobs setting to 16, premise OSD is worse than self OSD. And for the read test, it's versus the number drops equal to 16, Chrom's OSD is better. So it seems weird, right? Right is less number drops is better, and read is more number drops is better. And for the FL read, I can't set the big block size. It only can be set to 32 kbytes. If it's at 64 kbytes, the FL read cannot finish it. It seems something wrong when created the report. But I tried SeaStor has the same issue. And this is FL test has an issue for read. And for the test result, it seems Crimson couldn't give the better performance for the IOPS and the latency. And
yeah, we're seeing a task switching overhead for Alien Story here. Interesting.
Okay. So I found another problem. I'm not sure if you try it. When I build with the build for this one release version, release with debug information, and build the Crimson OSD. When I start up the Crimson OSD, I got some SeaStor memory.cc. There's some alert happened in SeaStor call memory.cc. There is alert happened when I start Crimson OSD. So I'm not sure if you meet this problem before.
Can you send an email with detailed error output for these two things?
Yeah, for this one. Yeah.
So it's probably that you were trying to allocate too much memory or something with the way Linux was configured. I've seen a few of those.
Yeah, I think it's something maybe with the allocator or something. So there's two problems. One is the release with debug info, and there's crash information for the memory.
Does that mean that the other benchmarks were done with debugging on?
Yes. I use debug mode, but the Crimson OSD and the SeaStor are all in the debug mode.
Okay, so those are essentially inadmissible.
Yeah.
Yeah.
So, yes, all the debug mode.
I think I'm questioning your methodology for testing Crimson OSD, because if the alienized store thread pool are using the thread in alienized BlueStore thread pool are using the core, which is also used by Crimson OSD.
No, SeaStor thread uses CPU 0, and Alien Store use, maybe I said it's 10 or 20. I forgot it.
Okay.
And hard code in the
I see.
Yeah.
Okay. So not a problem. Okay.
Yeah. So we have to figure out why Crimson OSD can't give the better performance.
No, hang on. Seriously, until you can test with debug info, with debugging turned off, that is relative debug info, which is an actual performance build, we can ignore these results. They're not meaningful.
So, but the SeaStor also run the same build.
No, I know, but it's still not meaningful.
Okay, I see. So that's
in other words, we can't even assume that Classic gets the same amount slower.
Okay, let's fix it first for the debug, for the release version, and so I updated the PR. So please review it again. Last week I already updated it.
Yeah. Okay.
Yeah. So that's all from me.
And why the write performance is lower than it's much better than read.
Again, it just doesn't matter until we fix the debug info thing.
Okay.
Just it's extremely misleading. It could just be an artifact of the way the debug code was built.
Okay. So
like SeaStor in particular depends really heavily on optimizations.
So then we will discuss after the release mode works.
Right.
Yes, please send the mail regarding to the results in memory.cc. because we do build the release build in the perf test.
And just to expand on a little bit on why why I'm worried about the debug build thing. All those SeaStor futures that are being passed around, many of those benefit greatly from inlining, like hugely. They're incredibly dependent on it. If all of those function calls actually happen, SeaStor is way slower than it should be. Does that make sense? Classic.
Sorry.
So Crimson SeaStor depends really, really heavily on function inlining.
Oh, okay.
It's very
Which
slow
is
without it. Yeah.
You see it when you try to do to open a debugger on it.
Yeah.
Nothing is there is nothing there. Only inline data.
I mean, don't get me wrong. Classic OSD depends on it too, but all of the internals of futures depend on all that templating requires some of the intermediate function calls to go away for it to work. So yeah, there's basically never a reason to publish IOPS numbers with debugging turned off or with debugging turned on.
Okay, so yeah, that's all from me. Please
So
read the
have
hierarchy.
sorry, have I understood correctly that the numbers in the presentation you published are not with the production build?
Precisely, that's a debug build. So I'm suggesting that they're just not.
Yeah, it's
Oh,
default.
okay. Well,
Default
we
is
could just
debug
ignore 'em.
build. Yeah, when I tried
yeah.
to set to released and it got crashed when the Crimson OS start up.
Oh,
In
okay,
the
okay, I see,
SeaStor
I
member.cc.
see. Ah, okay, now understood. Okay. Anyway, I
Yeah,
can
no.
fully agree that going with the debug build is especially painful for SeaStor application. Basically it boils down to the fact that it goes through a reactor. Every single clause, every single element of a continuation in SeaStor goes through the reactor. The need
Oh, yeah, I forgot
preempt
about that.
is always
There's
true.
that too.
It's a painful thing.
Yeah. Okay, so yeah, I forgot about that
Even
as
if
well.
it's an immediate future.
Yeah, there's debug code in there to make sure it always goes back. If you have debug turned on, it's artificial.
Yeah.
It basically
Yeah, it's
handicaps itself
extremely
on
inefficient.
purpose. It's there to make it so that you see more of the possible interactions through the reactor because you're debugging it, right? But anyway, in summary, Crimson in debug mode is crazy much slower than it even should be normally for whatever reason. Yeah. Anyway.
On
Yep,
the
send
other
us an
hand,
email.
we
We'll
need
help you figure out what the
admit that
config problem was. Sorry?
on the other hand, we need to admit that classical OSD was also getting a slowdown, mostly
Yeah. I did.
because of having logged enabled.
Radek, I'm not saying that this means that we did better. I'm saying that this means that the numbers are uninterpretable. So we should just wait until we have better numbers.
Agreed. But just to make sure, even after fixing the debug type, we still need to ensure the no log dep option for classical OSD for restart.
Doesn't it do that? Doesn't RHEL with debug info just disable it?
No,
Crap.
definitely no.
Okay, yeah, gotta disable that too. Whatever the release fix are.
Okay. Emno, how's it going?
Yes, hi. It's going pretty good. I'm still working on CBT as we discussed last week. Following last week, I told you that me and Radek were trying to come up with a solution to basically merge results from Rados, Bench, and Perfstat to get better, I guess, more complex matrices. And that's what I've been working on the past week. Tomorrow I should be already testing that because me and Radek already came up with a solution. I already wrote the code. And tomorrow when I will be at the office, I should be running and testing that to see if it works. And yeah, that's pretty much it for me now.
Okay, thanks. Radek, are you still on vacation?
Hello, yeah, I'm in some kind of tourist mode actually.
That's good. You should be. You're on vacation.
Okay.
Yeah, not so much work for Crimson. Just from before going on PTO, I made the part of Watch Notify that is related to handling ops is actually done. I have a branch. What left is basically implementing the Crimson's counterpart to classical OSD Watch CC. I was working on that on Friday. Another news is that two further patches for the SeaStor optimization have been merged. Avi also asked for renaming our method in another one. I will do that. It's not a huge deal. And basically that's it.
So there's only a single pending patch in SeaStar's dev discussion group.
Actually,
Says,
two of
looking
them,
for being merged.
but one
Okay.
it's the one before the last one. Actually, that's the thing. That's the patch Avi requested changing the names.
Okay. Thank you. Ronan.
Hi. Yesterday I published the first version of the iStock server. Thanks again. Thanks for the comments. Like we discussed in the beginning of this meeting, before everybody started, I'll make a simplification change, remove all gates from the code, and then we'll publish a new version. Now that this is more or less done, I hope to get back to mainline, main OSD SeaStor business. That's the idea. And one comment. Mark Hogan successfully compiled the stuff with Clang now and tested it. And I will go and try to compile our code and see what comments come up, what warnings come up when Clang compiles Crimson, and probably try to see if there is anything to fix there. And I think I talked about it once, but could we get Clang? Could we agree on a Clang format file for Crimson? Then I won't have to do all this counting blanks, beginning of lines, etc. And refactoring would be much easier.
That would be great for me. I mean, Emacs does that for me though.
Yeah, I'm using VS.
Huh?
We can apply Clang format to Crimson, a subset of Crimson if it's a lot of complaints. Otherwise, I'm all for using Clang format.
As long as it emits something that's pretty much what we already have, I'm all for it. Not
Okay.
that exists in the rest of the code base, which should be possible, but not wildly unusual.
I think we can match the existing code to some tweaking. I did it before. I think we can do it.
Yeah, I'm all for it. That's way easier.
Okay, good. I'll try.
I do want my 80 character.
And that's sorry.
Yeah.
I do want 80 character lines though. No, it's fine. We
80
can find it.
It's so small, you know.
Yeah, but the rest of the code base is that way. And that way you can keep a lot of windows next to each other.
Okay. Yeah. Okay. I'll go for it. That's it for me.
Jam?
Okay, the object context patch went in, so Radek, you should be able, when you're back, ought to be able to rebase that patch on that, and that should just work. I am writing a much more detailed design doc for SeaStor, starting from stages ideas. This isn't about the metadata trees, this is about layout. So the fundamental problem for really all Flash-based systems ever, including FTL systems, is the need to move data around while dealing with the fact that something somewhere wrote physical addresses down, right? So if we need to garbage collect a stream and move blocks, whatever, over to another stream, then everything that currently refers to that stream needs to be updated, right? Or to that segment needs to be updated. So the conventional way of doing this is dealing with an offset table somewhere, but that's more metadata, more writes, and more write amplification. So I'm trying to figure out if I can use something analogous to one of several log-based file system schemes, or write anywhere file system, good old-fashioned waffle, where when you do one of these moves, you also cascade that change up the metadata tree. It seems like it should be more expensive, but that cascade isn't necessarily more expensive than maintaining the offset tree. ButterFS works this way, if you've read the paper, for when it does need to do rewrites. So anyway, I'm writing, I can dump what I currently have to you guys over email. It's going to change. In fact, I'll just do it right now. I'll dump this to a file. Ultimately, I'm going to...
I think the SPDK and F2FS are both using the same approach for managing the stream. So I'm wondering what our take would be. I think that would be safe.
There's the basic approach, and then there's the fact we're not writing a file system, right?
No.
So we have a bunch of big fat advantages over a file system. We do not need to maintain any ability to do atomic renames across trees, for one thing.
Yeah.
Oh, I can't actually share this. Hang on a sec. Do you want to move on to the next person? I can do this in the background and then continue talking. Okay. I'm going to delete that. That document's not going to live forever. It's just though if you want to make comments on it, by all means. So I think one of the most important questions to identify early is the relationship between the cache and the way we do delta records on disk. So the scheme I'm leaning towards is pretty normal in that every logical block is either clean and has a location on disk, or it is dirty and it is located ephemerally in cache. And replaying the journal from the current segment through to the end will result in the same ephemeral copy of that block, right? In other words, you can replay the journal forward to get the same cache state. So on journal checkpoint, you then need to write out the dirty segments, or any dirty blocks you have to rewrite out. But the problem is that you then need to propagate those changes up the metadata tree, right? Because now the location of that segment changed. So my thinking is that we just do it recursively.
Sorry. We do it recursively?
Yeah. So we leave so like when we load something into cache and begin modifying it, we're writing out to disk deltas against that block. And delta could mean one of several different things, depending on whether it's a block or one of any number of metadata structures. If it's a B tree, for instance, it's like an ordered set of keys and values. So that looks like inserting a key into a block. For a regular data block, it looks like just byte range updates, right? Does that make sense? So different, which suggests that blocks are typed and deltas can be applied differently depending on the type, which is straightforward, not that complicated, except that it really is. The trick is that after you've loaded one of these blocks into cache and begun mutating it, it will eventually need to be written back out, either because of cache pressure or due to a journal segment. So that type thing will also have some kind of a dependency tree in memory. So we'll know that if we do try to write out this block to a new location, we need to update, I think, always one parent, which logically means it gets a delta in the journal and becomes dirty, and so on.
To put it another way, a block also has a future which could be fulfilled or not fulfilled.
That's exactly that's right, but I'm not gonna represent it that way, because blocks are just gonna have the same layout as they do on disk. So instead, there'll just be a secondary structure that remembers which other blocks need to be updated. It's not different from the future. I just don't think I'm going to use it for it. Like, this isn't a reactor thing. Like, we're not doing this in a deferred way. Like, yeah. Futures will be involved. They're just not the way I'm going to choose to represent that part. Mostly because all of this stuff needs to fit in a bounded amount of cache, because we have to be able to share cache pressure between this and other things that have to be cached elsewhere in the system. So things that occupy a lot of space like this need to have a pretty specific structure. That is, we want to do like linear allocations and bump allocations within this space and control how much of the cache is used just by doing direct flushes back out. Anyway, so most of that document is extremely rough, and ultimately, once I get into a slightly less crazy state, I'm going to submit a PR replacing the existing SeaStor.rst, so we can all review it and have opinions. But does that seem like a sane? And part of this is sort of enumerating the components, which will map onto interfaces inside of SeaStor, which will map onto files and classes we can actually write code for. That'll make it easier to define what we're all working on and where things need to fit. Does that seem rational?
Yes, I think so.
Okay. So just for one way of thinking about it is that, so a B tree, like your B tree implementation, so it will consume this block interface where it says, give me a block, and you get a buffer that you get to apply deltas to. And the buffer manager will maintain the in-memory copy of that block, and eventually, when it needs to be flushed out, you will have provided it code that is sufficient for updating the parent pointer in the block above it and dirtying it as needed. So all of the different consumers of this interface will get to provide those little bits of stub code to control how the cache flush out works. And I think that should ease some of the pain that systems like this usually get into as they get bigger. Early days, though. I'm going to focus next on reading all of the FTL and log structured file systems papers I can find. I've read a lot of them. Maybe have forgotten some of them. So I'm going to go back and reread some of the seminal papers, some of the more recent ones from FAST. This does have certain elements in common with the way hardware manufacturers have been building the on-disk flash translation layers too. The part I haven't really thought about much at all is how how to maintain the metadata structure that lets us figure out which stream we should clean next. But I'll get to that, I guess.
You mean choose a victim to be
garbage collection? Yeah, because
okay.
there are like a bunch of interesting trade-offs, because when you're doing garbage collection, you could choose to make a point of grabbing like a segment that maximizes the number of big write-outs you get to do from the same few objects, which lets you sort of combine compaction and also cleaning. I don't, but like your ability to do that is constrained by how you chose to write the metadata down. So interesting things we can do there.
Yeah, and we can even using different policies to choose the victims and to combine different operations to do.
So that's the other reason
in one batch.
That's the other reason I'm trying to decompose it this way. It's so that we have like an idea of what a GC does and how it consumes the disk, but that gives us a clean interface for writing tests and for writing more than one implementation as needed. Not that that's novel, but.
Okay, thanks. I will be commenting on your rough design. Any questions, guys? Oh, by the way, I will be on PTO in the following 1 week also, but I will be around for code review and etc. Okay. So see you next week, and have a good day and have a good night. Talk later.
Thank
Thank
you.
you.
Bye.
Same for you.
Bye. Thank you.
See you next week. Bye.